Okay, so we're going to take a little break today and do something fun. We are going to look at how 3D images might be displayed. In a module like this, you might expect a class on 3D environments to talk about how 3D environments are stored and represented internally in the machine. We're not doing that. We're just looking at how 3D pictures can be displayed. Okay? So, with stereo audio, you need two channels, they're called. You need to send one signal to the left ear and one signal to the right ear, and that's how you get stereo audio. For stereo vision, or 3D vision, you need to deliver a separate image to each eye. So you can get special cameras that take two images at the same time from slightly different angles. I'm surprised we haven't seen a smartphone yet that doesn't take 3D pictures. It seems to me like it would be all the rage. It would be easy to do. You just put one camera at one end, one camera at the other, and you turn it sideways, take a picture, you've got a 3D image. Right. And the distance then between the images would typically, ideally, would be the distance between a pair of eyes. Humans can see in 3D, and we have both eyes looking at the same thing, but the images are slightly different, and so we can perceive depth that way. That tells you that we're predators, actually. If you look at animals that are more likely to be eaten than those that do the eating, you notice a frog, for example, would have eyes on the side of its head, so it can have a wider field of vision, so it can see all around it. So if aliens come from another planet and they say, we come in peace, we're nice people, if the eyes are on the sides of their heads, they're probably telling the truth. If their eyes are the front of their heads, they're probably natural predators. So we evolved 3D vision probably to help us spot stuff that was being camouflaged. But anyway, seeing in 3D, depth perception is handy. So you need to capture one image for each eye. That's easy enough to do. You have a camera with two lenses, you take two images at the same time. Delivering a separate image to each eye has always been tricky. And so you can see all these antique Victorian contraptions. A favorite one was that you would have a mirror, and you kind of have a mirror on one side and you look in and you get one image to the right eye and one image to the left eye. All sorts of different knickknacks. So this here is a special viewer that could be used. It's kind of a modern one. But the Victorians were very ingenious. They had some great things. Now, an anaglyph is an image then that's viewed through special glasses. Colored glasses act as filters. Usually one is cyan and one is red. And filters are used, when someone has special glasses on, they're probably using filters. So a filter will only allow a certain kind of thing through. So a red filter would only allow red light through, and a blue filter will only allow blue light through. So the blue image won't pass through the red filter, and so the eye that has the red filter won't see it. So if you don't have the special glasses on, you see the image for the left eye and the image for the right eye at the same time. And what the special glasses do is they separate them out, so each eye only gets one. And there are a couple of different kinds of those. So only the red light will travel through the red filter, and only the blue light will travel through the blue filter. And so you manage then to deliver one image to each eye. Polarized light is much more sophisticated, and that's what you get in the cinema. When you put on, oh, feck, I had a pair of glasses on in my office blown, I forgot to put them on. But you might remember from physics class, and this is a physics book here, polarized light. Light has properties of both particles and waves. And if you were to visualize a light wave, it's traveling this way, and down like this, but it's also traveling in this plane here, like this. So it's like, it's coming at you two ways. And what a polarizing filter does, or polarizing lens does, is it filters out one of those. So you only can see like the horizontal light, so to speak, or the vertical light. And actually you can test if the polarizing lenses are any good, because if you get, say, two pairs of glasses and you hold them up, you should see, and if you turn one through 90 degrees, it should stop all the light coming in. So when you go to the cinema, you have two projectors projecting two images onto the screen. One is polarized this way and the other is polarized this way. So they're like polarized at 90 degrees. And when that bounces off the screen and comes back to your eyes, one of those is going to get through the right filter and the other is going to be completely blocked. And the other one will make its way through the left glass and the other one will get completely blocked. So each eye will only see one thing. So that's the trick when you're trying to create the illusion of 3D. The hard part is getting a different image to each eye. The polarizing system works well because you can have full color. Although it does actually reduce some of the intensity of the light, which is why if you look at a movie that's in 3D and you can make it out, the color is really turned up. It's very bright, the color is turned up really strong. Some people find 3D movies very dark, because there's so much of the light has been taken out of it. So if two images are stretched onto the screen, that was what I was just saying there. And that's how modern 3D in the cinema works. That's why you wear those special glasses. If you want to look at 3D on your computer screen, so let's say you're involved in making one of these movies, obviously you don't work with projectors, you just have a computer screen. How do you do 3D then on a computer? We don't have this, well actually we do have some displays that can do that, but in general what you have is again special glasses, and there's a lens on the glass that can close, it can blank off very quickly. So you can block one of the eyes, right? And it can happen very, very fast. And what you do is you block one eye and then you block the other eye. So you see the left image, and you see the right image, and then you see the left image, and then you see the right image, and then you see the left image, and then you see the right image. But that happens so fast that you don't notice it. So when you're looking at the screen, it goes left eye, right eye, left eye, right eye, left eye, right eye. So each eye gets a separate image. At any one time, you only see one, but it happens so fast, you don't notice. Although some people do report they get a bit car sick. Okay? So those shutters can work really well. And again, then you can see perfectly color 3D then with that. With virtual reality, you have a head-mounted display, and you have a separate image for each eye. And you also have the additional effect that the image that you see is generated dynamically. So if you turn to the left, if your head turns to the left, there's a motion sensor, and it will generate what you should see if you were looking over there. So as I turn my head, the image changes, and I appear then to be in a virtual environment. I've never done that myself, and it's easy enough to find a place where you can do it. People again report they get car sick because there's if the computer system isn't quick enough to generate the image in response to where your head is going, you don't quite see what you should see quickly enough, and people report getting a bit sick. But I'd say now they're super fast now. Probably find them in some leisure centre. There's a video game where you can get a gun and put on the headset and blast monsters in 3D and stuff. But the important thing about virtual reality is that it also tracks your movements. So if you're looking down at the ground, you'll see a picture of the ground. If you're looking up at the sky, you'll see a picture of the sky, and it's generated in response to what you're looking at, in addition to being 3D. QuickTime VR was a technology developed by Apple. It's largely not used anymore. Apple has a great habit of inventing things and then forgetting about them. This was a technology that allowed you to go into an environment and take a sort of a panoramic picture. Well, actually, I tell a lie, because much of the technology that would have been developed for that is now in my iPhone when I do a panorama. It's in there still. And this would allow you then to view panoramas. You could look up and down and turn around. It wasn't 3D at all, but it was a very good effect of being in an immersive environment. And you could do things there. No, so what I'm going to do now is I'm going to look at some images in 3D, and I'm going to give you some glasses, and we'll just have some interesting fun. Okay?